Good morning, everyone, and welcome to Autodesk Virtual Academy, brought to you by KETIV Technologies in sunny Brea, California. I'm Nigel Mbayak, application engineer here at KETIV, and your host for today and all days. I'm joined today by Alex Alvarez. As you can see, his name's there on the screen. How's it going, Alex?
Pretty good, not too bad.
Awesome. So Alex is actually one of our in-house, I would call him manufacturing expert per se. A lot of his skill set is, shines a lot in the HSM and CAM environment, and that's why we have him here today for you all to hear. So Alex is going to be going over, simplifying some CAM and Inventor HSM, kind of go over the differences in some of the, workspaces within HSM itself. I believe Alex is going to go over some of the key differences between things like milling and turning, some of those machining terminologies that some might not be as familiar with. We just want to make sure everyone's on the same page, and so on and so forth. So if you have any questions, definitely type them into the GoToWebinar chat panel at any time. We'll make sure to answer them during the session or at the dedicated Q&A. And I'm pretty sure that's it, Alex, right? Is there anything else?
No, you pretty much covered it. Yeah, that's what we're going to be talking about, CAM. Specifically in Inventor HSM.
There you go. Okay, so I'll go ahead and pass the floor over to Alex, and let's go ahead and get started.
Perfect. All right. So today's main objectives are, just going over CAM in Inventor HSM, right? So specifically, doing some turning inside of Inventor HSM. So we are going to learn about the differences between turning and milling, right? So a lot of people may not be too familiar with the two terminologies there. So just want to make sure again that everyone's on the same page and everyone understands the differences between those two different operations. Then we're going to program a part inside of Inventor HSM. So before actually posting out to the machine, right, a lot of times we see that people or customers tend to make changes to the models. So we're going to see how that affects our toolpath operations and how to handle that correctly inside of Inventor HSM, right? And then finally post out to our machine. All right, so the main difference between milling and turning, right, as you see on the screen, milling, you're going to have a tool that's primarily going to be doing the rotation, right? So again, you have an end miller going around the part, and the tool is the one that's going to do the rotation. And then on the other side, you have what we call your standard turning operation, right? Where the tool is not the one turning, but the part is the one that's doing the turning. The tool is going to be fixed, and it's going to go across the part, removing materials, right? So that's the basic terminology. Again, you can get a little bit more complicated and get into live tooling for the lathes, but that's a whole nother animal, right? So this is going to be the basics for milling and turning, just so you guys are aware of that. All right, so another key difference between milling and turning are the axis specifications, right? So as we see here, we have a part inside of a vise, and this part, if you notice, has a Z going straight up and down, right? So you see the guy standing over there on the top right. The Z is essentially going to go across the height of your body, where the x-axis is going to go horizontal, right, left to right. Y-axis is going in and away from you. So that's, again, basics on a vertical milling machine. So now on the turning operations, what do we have? We have the Z-axis going through the center of the part. Now, this is going to be important, right? So you want to make sure that you have this work coordinate orientation. Otherwise, you're not going to get the correct tool paths, right? When you bring in your tool, you start creating the tool paths, you're going to see that the tool is going to be maybe in the wrong orientation. It might be milling from a different side or creating the tool paths from a different side. So this is the orientation that you guys want to follow when you are doing turning operations. All right, so let's go ahead and jump into Inventor and demo this part, right? So we have this part. Again, if you guys have HSM, you are going to have this little CAM over here, CAM tab on the top, right? So again, we're in the 3D model, essentially environment here, right? We created the profile, revolve profile. We then revolved it along an axis. Now let's go ahead, create some toolpaths for it, right? So first things first, we want to go ahead and create our setup, right? So again, we have a different set of tools here on the top. The workflow that we want to follow is pretty simple, from left to right. Right? creating the setup, adding toolpaths, simulating the toolpaths, and then finally posting out to our machine. All right, so let's go ahead and start creating the setup. Again, we get a preview of our stock, right? So that's what the yellow shading is indicating to us. It's a cube right now, so we know that's not how we're going to start off. So let's change the operation type then to a turning operation. Right, so being that I was the one who actually modeled this part, I modeled it exactly how I was going to position it inside my machine, right? So that's why the z-axis is already pointing exactly through the center of the part. So we don't really need to make any changes there. Next thing what we want to do is make sure that we have the single model selected, which it is. Again, if we had a chuck or we had an entire assembly, you might want to make sure that you just have the model that you want to create toolpaths on selected, right? Now with turning, another little special feature that we have here is the spun profile, right? So again, if you have maybe some sort of drilled through hole, or maybe you have some sort of disconnection on the outside profile of the part, you want to make sure that you turn on spun profile. So when we get calls from people saying that they can't generate toolpaths on when they're using the turning operations, this is usually the culprit right here. So if you are running across those issues, you want to make sure that you turn on the spun profile for your part. Okay, so let's jump over to the stock real quick. Again, we have a fixed size cylinder, right? So if you're working from maybe some sort of a forging, or maybe we had multiple operations on this part, right? We're working maybe on the second operation. We can model the stock, choose the stock to be a from solid, and pick that body that we created to be the starting stock for our part. In this case, this is going to be a brand new operation, so we want to make sure that we start with the fixed size cylinder. Right, so we can increase it a little bit, 2.75 in my case, and just give it an arbitrary length. Right, we're not going to start with the same exact size here. And notice that it also positions it in the center of our stock. So let's go ahead and change that. Right, so we want to do an offset from front. Reason why we want to do that is so that we have enough material for the tool to come in and face off the part. Right, we want to have a nice clean surface on this front of the model here. Right, so again, give it a small offset, maybe 50 thousandths, 60 thousandths, right, just enough for the tool to come in here and clean up that surface. All right, so also in the setup dialog box, you see that we have a chuck reference, right? So a lot of people get confused with the chuck reference, thinking, okay, well, maybe if I set the chuck reference, maybe somewhere 3/4 of the way from the front of the part, if I generate a toolpath, it's going to give me an error saying that, hey, I'm going to crash into the chuck. But that's not necessarily the case, right? So the chuck reference is there solely to act as either a confinement, right? So you can, when you're creating the toolpaths, you can select the chuck reference as a confinement point. It's also used for your secondary spindle operations, right? So you can select where that chuck reference is going to be located, right? So that's where chuck reference comes into play. I personally don't really use chuck reference all that often, unless I do have some sort of secondary operation motions there. For the most part, though, that's gonna be it, right? We set up our stock. We made sure that our work harness system was oriented correctly. Give it a small offset, so we're ready to go. So let's go ahead and create the setup. Hide the first setup here. So now again, similar to milling, right? The first operation then is going to be a facing operation. So notice that now we're going to be focusing then on the turning toolpaths over here. Right? So starting off with the face, all we really have to do then is select the tool, right? So again, if you guys look up here, we have the same 5 tabs that appear when we're working with milling operations, right? So we have our tool, geometry tab. Instead of heights, we now have radii. We have the passes tab, and then finally the linking tab as well. Right? So let's go ahead and start off selecting our tool. So you do get, again, hundreds of tools already downloaded. But for turning, though, we have this small little sample tools library that we have, right? So it's only a few, but again, you can start off using the tools that are already in here, right? Copy the tools, and then bring them into your library and create those edits that way, right? So that's what I did here. Let me go ahead and start off then with this CNMT tool. And we get a preview of the toolpath as well, right? So again, if 50,000 is offset, that's what it's going to machine off. We can just hit OK, and it creates that toolpath for us, right? We can go over to the top, simulate that, and see what it's doing, right? So now what we want to do then is rough out some of that material, right? So again, we have a 2.75 stock. Let's go ahead and remove some of this material using a profile operation, right? And it's already on here. For some of you guys, it might be a little bit different, right? So I primarily use these toolpaths. So what I did then, right-click on the toolpath, change the button size to large, and it brings it up to the top over here, right? So if you guys use, some of these toolpaths as well, just feel free to do that. Change the button size also, right? So again, let's go ahead and start off with the profile. So let's see, we are going to be using that same tool. And let's just go ahead and hit OK. Let's see what kind of toolpath it gives us, right? So right off the bat, it doesn't look that great, right? So it's grooving into the part here. We do have a hole going through the center of the part as well. So it's trying to groove into there as well, right? So let's go ahead and do some changes. So right click, edit the profile, right? That's what's neat about this, is that you can always go back to the toolpath, make edits. You don't necessarily have to start from scratch. So if you look under mode and direction, right, we have this grooving option. Let's go ahead and don't allow grooving in this case, right? Now, let's go into the geometry tab, right? We want to make sure that it looks at the rest machining, right? So a lot of people think that it's going to be okay, it's going to machine the rest of the material. Really what rest machining means is remaining stock, right? So we already machined the front of this part, so there's no stock there. It's going to try to machine everywhere it can get into, right? Without grooving, of course. So let's go ahead and enable rest machining. Radii, I'm not going to do too many changes there. Let's go to the passes tab. Again, this is going to be a roughing operation, right? So let's make sure that we don't have any finishing passes there. And stock to leave, right? Let's go ahead and leave 10 thousandths on both radially and axially. Okay, let's click OK. Let's see what kind of toolpath that gives us, right? So right away, we see that that's a much better looking toolpath. It's not grooving into the part, right? Giving us some weird surfaces here for the grooving tool to come into. And it's not looking at the front of the model anymore as well. Right? So that was a much better toolpath. So now what we can do then is make our finishing pass. Again, we can go to the top, select profile, but if we already have, some of these parameters selected, we can just duplicate that toolpath. So while I'm looking at this toolpath, I'm also noticing that it's stopping right at the moment. We can actually extend that a little bit just to give our parting tool less material to remove, right? So let's go ahead and do that before we duplicate it. All right, so change the edits. That's going to be found under the geometry tab, right? So we want to go from the back minus 200 thousandths in this case, right? So now we have that toolpath extending past the back of the model by 200 thousandths. So now what we can do then is let's go ahead and duplicate that, right? So now we have two of the same toolpaths. Let's go ahead and make those changes to the last toolpath there, right? So we're going to change tools. This time we're going to use a sharper tool and give us a nicer surface finish on the part. And we're also going to change this right here, right? So it's not going to be a roughing pass, and we're not going to leave any stock on the model, right? So what we see then, it just gives us that one single pass along the profile of the part, right? Which is what we want. We want to smooth it out. So now let's go ahead and remove some of the material that's in here, right? So the operation that we're going to use to do that is going to be a grooving toolpath, right? So once again, knows which tool to use in this case. So let's go ahead and start confining that toolpath just so it focuses on this section here, right? So once again, we're going to be adding some confinements. So this is where it gets a little bit tricky, right? So where do we want to confine it from? You have a couple options here, right? Stock front, stock back. Notice that the chuck front is coming into play, right? So again, you can reference where you want to confine your toolpath based on the chuck reference that you initially posted, right? But in my case, I'm just going to use selection, right? So I'm going to select the front of the face here. Now, again, when choosing selection, you may want to be careful because, again, if the part does go or undergoes some changes, and let's say this face, changes in offset or changes in width, it might not pick up the face accordingly, right? So you guys want to be careful on how often you use this selection. In this case, I found it wasn't really too much of a big deal, so we can select that as a selection there, right? Again, if that didn't work, we can maybe pick a value, right? Something along the lines of maybe half of the width of the flange here. So that way, if it did change, the grooving toolpath would still pick up this opening right here, right? So let's go ahead and go to the passes tab now. So everything here looks good. We can remove a finishing pass, right? Just so it gives us a nice little, just the grooving toolpath here. And we also have a couple options here for the grooving pattern, right? So we have the full step down, partial step down, sideways with partial step down, right? So if you guys weren't familiar with these, just hover over the options and it gives you, the dialog box comes up and it gives you a little picture of what that option is going to be doing, right? So we can use this one, sideways with partial step down. Just select OK. Right, so there's the toolpath there. Okay, so now let's go ahead and move into our hole here, right? So once again, we can do a drilling operation. We're going to be using the same drilling operation that we use if we were using a milling model here, right? So it is going to be a 3/4 inch drill. That's going to be fine. Hole face is going to be this hole face here. But let's take a look at the toolpath real quick, right? So we see that it's yellow here and then it turns green, right? So for those of you that don't know, yellow is going to be a rapid movement. So the machine's going to go as fast as it possibly can up to this green point, and then it's going to machine or go at the feed that we specified, right, for the toolpath. Now, the only issue there is that we haven't machined this hole here, right? So what's going to happen is if it rapids into up to this point, it's going to crash into the front of the face there, right? So it's possibly going to break your tool and definitely damage your machine, right? So let's go ahead and change that. Change that height, right? So instead of a whole top, for the top height, let's choose the model top, right? So now we see that the green line is going to be 200 thousandths off the front of the model, right? So it's going to feed from a safe distance here and then go into the hole accordingly there, right? So we cleared that issue. Now the bottom height, right? So the drill isn't drilling through the hole. Let's go ahead and change that again. Just click on the checkbox. The breakthrough depth, give it a small value of 0.1. Right, a lot of people get confused thinking that it's supposed to be a negative value, but it's not. It's supposed to be a positive, right? You want to break through 100 thousandths past that model face. All right, so for the drilling operation, we also have this last tab called cycle, right? So what kind of cycle type are we going to be using? Is it going to be deep drilling? You want to use partial retract, right? Chip breaking. In this case, that's what we're going to be using. And just define our pecking depth value. 150 thousandths is good for this case. All right. Again, we can simulate, make sure that we're on the right path so far. Fast forward through a few of these tool paths. Right, so that tool path, I don't know if you guys noticed, but it started creating those tool paths or machining from the top of the stock there, right? Which we had already machined. So let's go ahead and see exactly what's going on. Yeah, so it's starting to machine over here on the top. Again, that's the simple change. Let's go back into that tool path. Change the radii there. So the radius, the outer radius is going to be the model OD, right? The model outside diameter. Okay. So now the grooving toolpath, right, it's going to stay to the top of that model there. All right, so we're almost done here. One of the last steps then would be to bore out this little section here, right? So let's go ahead and do that. That's going to be, again, a profile operation. Now, this is a toolpath that a lot of people tend to struggle with, right? So the first thing that we want to change is the mode. It's not going to be an outside profile. A lot of people think that it's going to be a face profiling, right? But it's not. It's going to be an inside profiling. Face profiling would be used when you have some sort of a ring, right, or a groove on the face of the part. That's when you would use the face profile. Right? In this case, we want to bore out the little section there. So we selected inside profiling. Next, let's go ahead and select our tool. All right, so again, it's from the samples tool library. Let's go ahead and select this turning boring ID boring tool. Select that one. Now, one thing to note is that I am going to be using the tool from the samples library, right? So it's not going to give me the correct representation to the tool that I might have outside on the machine, right? So that's one thing that you guys can do, though, is model the tool holder. In this case, probably like a half moon, right, or crescent-shaped tool. That way we know that it clears this hole here, right? In this case, it's not going to give us the correct visual, right? So just keep that in mind when we're simulating. All right, so the next tab that we want to focus on then is the radii tab, right? So again, just these two tabs are the tabs that we want to focus on when creating that boring toolpath. Okay, so the clearance, typically I like to work from the top down. In this case, I'm going to work from the bottom up, right? So the clearance, what's the clearance referring to? So I just drilled a hole that was 3/4 inch in diameter, right? So clearance, think of it as a parameter. Give the tool some sort of a parameter to stay inside of essentially that parameter, right? So if you think about it, we just drilled out the hole that was 3/4 inch in diameter. So again, if we were to put 3/4 inch, it might go straight to the edge there, and it can possibly crash, right? So you want to make sure that you go a little bit below the diameter that you drilled out, right? So 0.7, maybe 0.65, right? Just if you wanted to play it safe. Now the inner radius, where do you want to start that toolpath? We want to start it from right here, right? That's the edge of the circle. The outer radius, where do we want to go up to? We want to go up to the edge of the circle here. Right. Click OK, and it gives us that toolpath there. Right, so the last step is going to be parting the part off. So again, that's going to be a simple part toolpath. It knows exactly which tool to select. If we see, though, it's going to go to the center of the part there. We can change how deep it goes, right? So the inner radius, we can change that to be a diameter and change that to 600 thousandths, right? 0.6. We don't need it to go necessarily all the way to the center of that part. So let's go ahead and hit OK and simulate the toolpaths that we have. So it's going to face, it's going to profile, it's going to give me the finishing operation, it's going to groove, it's going to drill, right? So here's our boring toolpath, right? And it's going to part the part off there, right? So that's the operations that it takes to machine this model here, right? So now what we can do then is post out to our machine. But right as soon as we're going to post, either the machinist or the customer comes back with us, comes back with changes, right? So how do we handle that? In this case, I modeled this this part using parameters, right? So if you guys weren't familiar with Inventor or with parameters, your parameters are going to be found up here on the top, right? With this little symbol here. Now, parameters are great, right? Because again, if you're maybe driving this part or the changes through iLogic, you can reference the parameters that you have created and change them that way. Or you can just go directly to the parameters dropdown and then make those changes yourself, right? So in this case, that's what I'm going to be doing. So what I do want you guys to note is look at the part as I'm changing these values, right? So they are going to be changing automatically here. So change that to 0.4. Second step down, let's say 0.55. The flange width, right? So this is going to be a big change here. So 0.5, let's try that one. And then the depth, which is referring to this boring toolpath, the boring section here, right? So change that to 0.28. Right, so we see there that it decreased in depth there. All right, so let's go ahead and hit done there. And if we look at the toolpaths, right, so now the toolpaths are essentially out of date, right? So we made changes to the model. Hey, go ahead and regenerate those toolpaths. Now, again, some of them may not regenerate fully. So if they don't, just go back in there and reselect some of the geometry that got changed, right? In this case, if we look through them, though, we see that all the changes did go through, right? So again, that saves us. That's huge because oftentimes a lot of people are having to go back into the entire setup and make those changes or create the entire setup that we just created right now, right? So here we just simply regenerated the toolpath and it was automatically able to pick up all those changes, right? So if we simulate this one more time, grooving toolpath there. Right, so notice that the flange width did change, but it's still picking up that back length there. Drilling operation. There's a boring toolpath. And then finally parts off the part. Right. So again, fully regenerated the toolpaths and it picked up those changes. Right. So now what we can do then is finally post out, send it to our machinist, and run the part. And there's our program there, right? So notice that you can set a spindle speed when you post out your machine, right? So that's another common question that I get is inside the post, you do have a couple properties here to work with, right? One of them being setting the max spindle speed, right? So once you maybe set it to, let's say, 2500, you set that max spindle speed. If any of these toolpaths are in excess of that, then you are going to get some sort of a warning telling you, hey, this toolpath is going past 2500. Don't run the post or don't run the program. Right. Let's go back here. So yeah, that's pretty much what I had for today's demo. Again, we're showing you how to handle a change in your model, right? That's something that maybe not a lot of people are going through, but that is something that's sometimes common inside the workspace or the machine industry, right? So that's how you would handle it inside of Inventor HSM. Hope you guys picked up a thing or two.
So with that, we'll go ahead and just jump into some questions. Alex, do you want to do that real quick?
Yeah.
Too?
Yeah, let's go ahead and do it.
So for HSM, when you're making the edits to your model in Inventor, what happens if you get a non-native CAD file type into it? So say, for example, you're importing a SolidWorks file into your Inventor model, and then can you do CAM off of that SolidWorks model, or does it have to be an Inventor model?
Yeah, no, you definitely can. I mean, it doesn't really matter. There's tons of different file types that you can work off of in Inventor. And yet, same exact way as if it would be an Inventor part, right? It just creates the toolpaths. It automatically picks up the body. Again, sometimes if it's, let's say, an IGES file, right, you might have to create a stitch or maybe make some sort of edits to the surfaces.
Yeah, as long as you have a solid body,
Yep.
you should be good, right? If you have a mesh, you might have to make some changes to that.
Yeah.
So
Yeah.
just note that information right there. So let's go ahead and keep going here. Alex, if you could do this really fast, and I know you're generally pretty fast at this, can you go ahead and demo a change of the work coordinate system?
Yeah.
Say, for example, somebody did it incorrectly. You want to do that really fast?
Yeah, let's go ahead and do that.
This is really important for people who maybe didn't model the part themselves and need to make an edit to the WCS. Let's do that. Let's just flip this guy completely backwards, maybe, start from the other side.
Okay.
I don't know what would do that, but for example, let's just figure something out.
Let's go ahead and regenerate the toolpath, see what it gives us. Right, so something like this, it might, let's see. So it gives us a face.
Yeah, sometimes it's going to be backwards.
Profile. Yeah, so I mean, if we were doing maybe secondary operations or secondary spindle operations, right, something like this, notice that it still picks it up, which this is actually pretty impressive. So this one we can either suppress it, right? So suppress that toolpath, and then it parts it off, right? So let's say hypothetically speaking that we're starting on this end, again, you can just change that work corner system, right? And it automatically picks up those changes as well, right?
Yep. So to do that, you just go into your setup and you edit it. And then one of the options there is to orient your model. And that's pretty much what Alex did. So it's right there, WCS. And you just select what axes you're using, so on and so forth. So that's how you do it. And you just, you can use faces as references and stuff. Makes it nice and easy. So hopefully those of you who maybe have received some parts in the wrong orientation, need to edit those. That's the easiest way to do it. So just jump into there. All right, let's see here. What else do we got? Let's go on through a couple questions. Do you get full 5-axis HSM in the product design and manufacturing collection? Go ahead, Alex, and answer that question.
Yeah, yeah, you do. Yeah, sorry about that. I was looking at the. I was still pretty shocked at the toolpath how they regenerated when we flipped the work harder system. But yeah, you do. You do get full 5-axis, simultaneous and indexing, right? So 3 + 2, 3 + 1 as well. So, yeah.
Cool. Yeah. Hopefully that answers some of those questions. I know there's some question about what's included, what's not included, and hopefully we answered some of those for you. It's HSM and HSM Works too. Yeah. So if you're in SolidWorks and you need to do the same thing, the environment's pretty much exactly the same in that tool as it is in here. So HSM for Inventor, HSM for SolidWorks, it's all in the collection. So those are some interesting things as well. And yeah, that should be it. So again, thank you everybody for being here, being part of our community. It is the community that is a driving force behind us doing these. So as long as you guys are supporting us in this AVA, and I guess I wouldn't even call it a it's just community. Yeah. We'll just call it that. If it isn't for the community, we wouldn't be doing these. So thanks for the support over the last couple of years. We have over 100 of these videos, and hopefully we end up getting to like 1,000 or something. That'll be a couple of years down the road, I guess. So with that, thanks everybody. We'll see you all next week.